Okay, so now we're going to look at the length of an arc. So in the same way that a sector was an area that was bound by the circumference and two radii, an arc is part of the circumference that's bound by two ends of radii. So this shaded area is an arc. Similarly, this is an arc, this is an arc. It's simply part of the circumference of the circle. And we work out the length of that arc by, again, looking at the proportion of the circle that the arc takes up, and then multiplying that by the circumference that we can work out using our 2 pi r. So again, let's look at this first one. This is 180 degrees. So 180 degrees divided by 360 degrees for the whole circle to get our proportion is a half. So this is going to be a half times 2 pi r. 2 pi r is the circumference of the whole circle. So simply put into our calculator, 0.5 times 2 times pi times r, and r is 5, and we get 15.7, and that's obviously centimetres. So all we've done is taken the proportion of the circle that it is, worked out the circumference of the whole circle, and applied that proportion. Let's do the second one here. This is 90 degrees. As we saw before, 90 degrees over 360 is a quarter. So this is going to be 1/4 times 2 times pi times r, because the 2 pi r is the circumference of the whole circle. So a quarter is 0.25 times 2 times pi times r, and r is 5, and that equals 7.85, or 7.9 to 1 decimal place. And then finally, again, we're going to take the proportion. We know that 30 degrees as a proportion of 360, cancel the zeros. 3 over 36 is equal to 1 over 12. So we get 1 over 12 times 2 times pi times r. So bring in our calculator, we're going to use our fraction button this time. So fraction 1, 12, so 1 over 12 times 2 times pi times the radius, which is 5, equals 2.6 centimetres to 1 decimal place. So all we do is we find out the proportion and we multiply that by the circumference of the whole circle. Very straightforward, very similar to doing the sector, except we're using the circumference rather than the area.